Hello and welcome. We know many of you are watching us from around the world, so good morning, good afternoon, and good evening. I'm Jonnie Lee, the Senior Manager of Lenovo's User Experience Design team that supports our Think Reality AR/VR business. Together with my colleagues, Nate Hatfield and Karen Kluttz, we wanted to share with you a glimpse into our design process and share some of the best practices we've built over the last few years designing in this space. We believe that these design principles will be critical in the next evolution of XR products in order to create truly immersive user experiences for everyone. Now, 3D experiences requires a completely different set of design practices, as well as unique skills and talents. Building a great design team takes time, patience, and a thorough understanding of the holistic solution, blending hardware and digital experiences into one. Our global multidisciplinary UX team consists of highly specialized talents with diverse backgrounds and skill sets. From UX designers to human factors engineers, Unity prototypers to scientists, we are driven by a natural entrepreneurial spirit to create the world's best experiences for our users. Guided by Lenovo's mission to create smarter technology for all, our UX design team is focused on creating lifelong customers by inspiring trust and consistently providing experiences that exceed expectations, whether at home, school, or at work. It is now more important than ever that we ensure that the products and experiences that we design are diverse, inclusive, and accessible to everyone. As we forge new emerging technologies, our team will continue being the voice for underrepresented groups while ensuring we maintain our highest standards for design, quality, and craftsmanship. Now, as the #1 PC company in the world, we know how to design innovative products. But when it comes to these emerging technologies like AR and VR, we must adapt our current design methodologies to reflect the complexities of these novel experiences. For us, this is not only a shift in our design practice, but it's a natural integration of more user engagements throughout the entire process. With these new interactions, we challenged ourselves to stay disciplined and not move on to the next stage until we were confident that the research guided us to make the right design decisions. By adapting to this new model, we are now truly driving user-centric design in order to create meaningful and immersive user experiences for everyone. Now, traditional user experience design centers around the product experience. Good designers will take a look at customer engagements one step before and one step after. Great designers, however, will look across the entire customer journey to identify additional opportunities to elevate the end-to-end user experience. Here at Lenovo, our UX team works closely with our customer experience team to help discover these opportunities, to create both an elevated customer and product experience. We know that many of our customers see our XR products as a turnkey solution. So we've refocused and reset our focus to look at these entire customer journeys. Finally, it is important to remember that each customer has a different journey. By looking through the lens of each individual, we're able to address their needs more quickly and more accurately. As more XR products hit the market, user experience will become a critical and deciding factor in differentiating our brand from the competition. I would now like to turn it over to Nate Hatfield, a human factors engineer for Lenovo's emerging technologies, to share his expertise regarding UX research and hardware usability for our XR solutions.
Thanks, Jonnie, and hello to the virtual audience. In the following slides, I will provide a glimpse into the principles and methods that we use to identify user needs in order to advocate for our end users throughout the design process. First, I want to highlight the importance of diversity for design. The UX team at Lenovo really strives to include diverse user populations in our research pipeline. Because as UX researchers, we understand that diverse samples will generate diverse feedback, and diverse feedback will then propagate generalizable results. So in the upcoming slides, I will harken back to the need for diversity. Let's talk about research. Front-end analysis work is really geared towards carving out the problem space and identifying user needs early on, and is essential when seeking to create emerging technologies that may have little to no pre-established standards. Some methods that we typically use in this first phase of research are simple literature reviews, which can help us determine what research already exists in the field and where the gap areas might lie. So for example, there may be ergonomics research that has identified the weight limit for a head-mounted display, but not how to distribute the weight along the user's head in order to optimize for comfort. Literature reviews are a great way to tease out early requirements or generate research questions that seek to address unanswered questions. We may also conduct ethnographic research, where we observe users in their work environments, such as at a factory, a power plant, or even visiting an office space. And this allows us to understand those nuanced interactions, behaviors, and environmental factors that need to be considered when designing both AR hardware and software. Understanding this context of use and how the user, which is a biopsychosocial system, operates in a larger system can help us zero in on specific user needs. In parallel with ethnographic research, we will also conduct user interviews to extract users' tacit knowledge about environmental constraints, task performance, and technologies to validate initial assumptions that were generated by the literature review or the ethnographic research. Customer interviews are really important because users may only be inclined to show and not tell. And as user researchers, it's our job to uncover those cognitive processes that underpin task performance. Another method that we might employ is task analysis. Task analysis is one of those traditional human factors methods that allows us as researchers to map out manual and cognitive activities in order to deconstruct the workflow. Task analysis is designed to understand the step-by-step nature of a task and the visual, auditory, haptic, and sometimes even olfactory cues that confirm task success or failure. So there are many tools that can be used to model the problem space, but it's important to keep the user at the focal point. Here's an example of the type of hardware testing that we might perform. First, we want to select participants that represent the range of physical characteristics present in the intended design population. This selection means that testing the average consumer may not be as informative as testing consumers at the extremes of a population distribution, especially when it comes to evaluating prototypes. Second, we want to ensure that we simulate tasks that are similar to the workflows that we observed during our ethnographic phase of research. This is important because we want to evaluate how various form factors might enhance or hinder the user in their work environment. So we may design a task that requires the user to move equipment around in order to see if there are differences in behaviors or orientations of the head that may be influenced by the head-mounted display. Third, we also want to understand how well the headset fits various head dimensions and hairstyles so that we can accommodate unique expressions between and even within populations. To that end, we will take head measurements across key landmarks such as the bridge of the nose, the length of the head, the distance between the ears, and determine how well the device affords the user with a good fit and comfort for both short and long-term wearing episodes. Then lastly, we may also include interchangeable parts in the prototype to allow users to quickly swap out different materials, shapes, and sizes, and provide immediate feedback about their preferences across these different design combinations. For example, we may allow the user to swap out different size nose pieces or different tempo lengths to determine what combination provides the best scalability across a diverse population. When it comes to software research, there are several quantitative and qualitative methods that we will employ. For example, We may start with a card sorting task that requires users to organize content into meaningful categories in order to inform the layout and information hierarchy of a UI concept. We will also develop prototypes and ask users to complete a series of predefined tasks to evaluate the navigation efficiency between competing designs. Similarly, there may be instances in which we want to uncover more granular insights through the use of eye tracking. Eye movements can be thought of as a gateway to the mind, so eye tracking serves as a valuable tool for understanding how the arrangement and saliency of content on a UI screen directs the user's attention when completing a task. We will also use other subjective metrics to capture usability insights, such as the System Usability Questionnaire, which provides a high-level assessment of usability, or the NASA TLX scale, which provides an index of cognitive workload as it pertains to preferences of frustration, effort, temporal demand, pressure, and mental demand when working through a set of tasks. Taken together, these metrics allow us to understand how efficient and easy to use our design concepts are as we improve from one concept to the next. Okay, so now I want to spend just a few more moments discussing some rules of thumb that we have used when designing hardware. To return to an earlier point, we first want to understand context of use. Is there any equipment that the user wears that we should account for in our design decisions? For example, maybe users in our enterprise market typically wear hard hats, gloves, or safety glasses. With that in mind, how will our headset interface with these items? Maybe there needs to be accessory attachments to connect the head-mounted display to a hard hat. Or maybe the use of gloves introduces a trade-off between capacitive touch controls and mechanical buttons for commercial and consumer use cases. These insights are critical to understand how we can advocate for an extensible design. When designing hardware, there is also keen interest in finding ergonomic absolutes. For example, eye relief, which is the distance between the exit pupil and the display, and panoscopic tilt, which is the angle at which the bottom of the frame or display approaches the cheek, are both essential for good viewing experiences. We want to find those absolutes early on and ensure that we maintain them across iterative changes to the design. We also want to account for anthropometric variability. Anthropometry is the measurement of anatomical landmarks and how such landmarks inform the dimensions of a design. So for example, European head profiles tend to be more almond-shaped compared to Chinese head profiles, which are squarer. Nose bridge profiles can also vary substantially across demographics, with some nose bridges being more pronounced and others more inset. The position of the ear relative to the forehead plane can also vary upwards of 15 to 20 millimeters between males and females. And the distance between the center of the pupils, known as interpupillary distance, can also vary upwards of 15 millimeters between males and females. This range of difference between and within populations introduces key discussion points, trade-offs, and even opportunities for innovation. In addition, we also want to look beneath the surface and map out where a head-mounted display makes contact with the body in order to mitigate pressure points. So the arms of a pair of glasses will likely make contact with the superficial temporal artery, which runs just in front of the ear, as well as the posterior auricular artery, which runs just behind the ear. When too much pressure is applied to these arteries, the user may experience heightened pain and restricted blood flow. With these factors in mind, that tends to lead us into conversations about material properties and how to pad certain areas of the device. And accessibility. As I mentioned in some of the previous slides about diversity, we want to make sure that we are also designing with an eye towards accessibility. There's a great quote by Professor Gabriel Savindi, which states that disability is the inability to accommodate to the world as it is currently designed, and augmented reality is not excused. For example, there may be opportunities for users with visual limitations to leverage a camera suite on a head-mounted display when navigating through a grocery store. Or users with auditory impairments may be able to toggle on haptic feedback when receiving notifications. There's still a lot of work to be done in this space, and I believe as a UX community, we have a responsibility to invite a larger audience to partake in the overall experience. So hopefully, I gave you a glimpse into our research process and some of the steps that we take to harness the user's voice when designing emerging technologies. Okay, now my colleague Karen will take you through AR design process and practice.
Okay, thanks, Nate. You know software UX can't do its job without the insights from the research team. So I really appreciate your efforts. Why is my screen not advancing? All right, go. All right, I'm sure this diagram looks familiar, and not just because Nate showed it to you a few minutes ago. Our process for designing AR is rooted in the classic customer-centric principles, but with more feedback loops built in. I'm going to hit on the big 3 steps, ideate, prototype, and design specs in a second. But first, a quick word about the importance of the data collection and problem identification steps for the UX team. I can't design if I don't know who I'm designing for, and if I don't know what's important to that person or the environment in which they're working. Having that information, it lets me accurately prioritize what appears on the screen. And then this information comes from those first 2 steps. Once I understand those qualities, it's time to roll up the sleeves and work on the ideate and prototype steps. Ideating, that's generating a lot of concepts, some of which don't go further than just paper and pencil, but that's okay. First ideas aren't usually the best. But as I ideate, I'm also using those first 2 steps to define the success criteria for judging the design ideas. These heuristics are rooted in the data and the problem identification steps, but the whole team will use them to narrow down the number of concepts we have and to figure out what to carry forward into the user testing. And it's these concepts we want to bring to life in the prototypes. There's no substitute, no emulator that fully captures the experience of an AR app in the headset. Prototypes, particularly the Unity-based prototypes, are key. And these prototypes are part of the bundle of deliverables that make up the design specification. So let's switch gears and talk about some of the best practices for designing an AR that I've learned. Can't use black because of the additive displays. I've learned I can't control the background of the user's lighting or the user's environment. What I may not see, I may not see what the user sees because of eye relief or just the variations in facial architecture of humans. All these may make a difference in the amount of the field of view the user sees as compared to what the hardware can provide. I've learned I need to use bigger, heavier fonts than I originally thought. I need to make larger controls or larger selectable targets, and white space is just as important in the AR world, and in fact, sometimes more important than the actual objects on the screen. But we do have some new tools, so let's talk about depth in AR. Depth is that 3D environment, a true 3D digital environment, and it gives me the flexibility of spatial positioning and allows me to take advantage of the space around the user. Although this can be a challenge in making sure the user keeps control of the environment so nothing gets lost. The way UI elements are used in the virtual space affect the user's performance and physical comfort. For example, it's much more comfortable for us to move our heads side to side than vertically. On our phones, we're used to scrolling vertically, and that's easy for your thumb to do, but in the headset, vertical scrolling strains your neck muscles. So I've learned that you can't just port an experience over from another device. You need to consider the physicality of the interaction models along with and sometimes realign those experiences along a horizontal axis or rethink the experience to remove paging and scrolling whenever possible and deliver the content in a different way. So we sometimes call user comfort usability. So let's dive into that category. I recommend overloading on affordances and feedback. And distractions happen, particularly in the AR environment. There's motion in the user's peripheral vision, there's sounds or sudden noises. These can pull the user's attention away from our UI. But those real world cues actually may be really important to our user safety. So this means my user will have less cognitive budget to apply to the application. So my application needs to work harder so that user doesn't have to. So flat design is a trend we've seen in PCs and the web and phone for several years now. It's not great in AR. Flat design depends upon the users exploring or browsing for what they want to interact with. Right now, nearly all our users are new to the environment. New users don't always have the time or the know-how or even the confidence to explore the UI. They need to be focused and they need to have the experiences brought to them with obvious next steps and obvious controls. And having said that, I think it's really important not to hesitate to leverage useful existing patterns and interaction methods. I recommend using familiar controls whenever possible. There is a temptation in AR to design like a super sci-fi kind of environment, and I think that works great in some use cases. I think it's kind of a different story for our commercial customers. Our commercial customers are looking for ways to improve their efficiency and effectiveness of their performance on the job. Again, I want to reiterate how we need to respect the audience and his priorities and his environment. And part of that respect entails accessibility. Now, originally, accessibility was created to ensure technologies accommodate people with varying impairments, but good accessibility principles are very useful in AR design. You might think your audience doesn't have any impairments, but imagine the scenario. Your user may wear heavy work gloves to do her job. With them on, she can't use small buttons or a touchpad, or she doesn't wear heavy gloves, but instead she needs both hands to do her job while still accessing all the digital content. So alternative input methods like voice or head tracking, gaze control, all would be very useful in the scenario, just as they would be for somebody who has motion impairment. So what started as an accessibility accommodation on a PC or a website are actually best practices in our AR environment. I feel it's key to think inclusively about the variety of physical and cognitive qualities that we all share and how these qualities can affect the design decisions that we make in our applications. I'm learning more best practices every day, but let's talk about how we communicate those best practices through our deliverables. Our deliverables are deliberately flexible at Lenovo. And by this, I mean the team and I provide a whole range of deliverables to support different audiences, both internal and external. Externally, we provide a UX guideline for people who are learning how to design for AR, but we also provide a design system that we're currently updating to provide the building blocks for creating GUIs quickly that'll provide good experiences. We also create classic UX deliverables like concepts and storyboards, wireframes, or task flows, but we've really ramped up on these prototypes. I know I mentioned it earlier, but I'm just going to hit that again. Our prototypes vary from very simple, like little animations that communicate how a transition might occur or how a component works, to full system interactive Unity-based mock-ups of the UI that we can put into headsets. And these realistic mock-ups allow us to do testing, A/B testing with users in real headsets and get much more accurate and realistic feedback than we would get from other methods. We can also use these prototypes as accurate models for the development and quality teams. So when it comes to start building the software, they pretty much have a good idea of how things should run. At Lenovo, we're building an AR UX innovation engine team, a team with the right skills and know-how to create effective AR content that will deliver great user experiences going forward. I'd like to share a lot more, but I'll save that for another time. Thank you for your attention. Jonnie, would you like to give everybody a sneak peek into what's coming?
Thank you, Nate and Karen, for sharing some of our UX best practices. Now, before we close, we would like to send you off with a sneak peek at an experience we've been working tirelessly on for the last several months, and we're incredibly excited to share it with you all very soon. It's a culmination of everything we've learned, from designing previous products in this space to actively listening to our customers. On behalf of Nate and Karen and the rest of the user experience design team here at Lenovo, we thank you for joining us. And wherever you are in the world, please stay safe and be well.